These are the notes for dilation and similarity. The notes on dilation and similarity are going to be broken up into two parts. So this is part one. In this first part, we're looking just at some definitions. So first, we want to talk about the fact that dilation is a transformation that enlarges or reduces the size of a figure by a given ratio through a given center. You'll want to remember that transformations, that we've talked about transformations, but we've only talked about rigid transformations up until now. And those are rotation, reflection, and translation. So we're now adding a fourth transformation. However, this one is not a rigid transformation. So similar to the rigid transformations, however, dilations do preserve angle measures. Those do stay the same. And they do have corresponding parts. However, the corresponding pre-image and image lengths are now proportional. They are not congruent in the way that they were for rigid transformations. We also know that when we have a pre-image and the image lines that do not go through the center of dilation, those lines turn out to be parallel. And we'll look at that a little bit further later on. The process of dilation produces similar figures, and those figures have the same shape but different size. So this idea of same shape are the angles, corresponding angles are congruent, and different size, this is the lengths being in proportion. So the very first thing you often see when you're looking at dilation and similarity is talking about writing some ratios. So when we're writing ratios for dilation, we want to create a ratio that has the corresponding lengths where it's the image to the pre-image. So I'm looking at these two triangles, ABC and DEF, and they are similar, because the angles are all congruent. That is enough for triangles, and we'll discuss that more in future sections. And so now I need to match up the corresponding sides. So because where the angles line up, I know that AB corresponds to DE, and BC corresponds to EF, and AC corresponds to DF. But my ratio needs to be written with the image number first. So this is our image. So I'm going to say 20 over 10 equals 12 over 6 equals 14 over 7. And those all equal 2. So we say here that our ratio is 2. If, by any chance, these three ratios did not all equal 2, that would mean that these triangles, these figures, were not similar. So this is a nice check to make sure that you have indeed do have similar figures.